Okay, so we're going to look at trying to undo the FOILing process or the distributing of two binomials. And so we're given, in all these problems here today, we're given a trinomial that we are trying to factor. And to start with, all of the leading coefficients are going to be 1, which means that the number in front of the squared term is going to be 1. So that way it's a little bit less for us to have to worry about right here when we're first learning how to do this process. Now, the way that you do this is you try to find all of the factors of the number here on the end, the constant on the end. So I'm looking at positive 7. And that's a prime number, which means that the only two numbers that can multiply together to make 7 are 7 and 1. And so I find all the factors that make that back number, and then I want to see if I had more than one group of factors. I want to make sure that if I select the two factors that add up to be the number in front of the non-squared term. And so if I check the factors 1 and 7, they add together and they make 8. So how this factors is like this. I'm going to make two sets of parentheses that would multiply to each other. And I think about what makes 1m squared right here in the very front. Well, m times m would make m squared. So I'm going to put m in the front of both of those binomials. Now, since both of these signs here, I have plus and plus. Since they're both pluses, that means inside of these binomials, I'm going to have two plus signs. And then the factors, the only factors that we had that multiplied to be 7 and added up to be 8 was 1 and 7. So one of these is going to be m plus 1, and the other one is going to be m plus 7, and we have it factored. Now, it's always a good idea when you're first starting out to double check that you did it correctly by multiplying this thing out and seeing if it's right. So I'll start m times m makes m squared, and then m times 7 makes plus 7m, and then I'll do 1 times m makes 1m, and 1 times 7 makes 7. And if I combine the two middle terms here, I end up with m squared plus 8m's plus 7. And so we ended up with the problem we originally had, which means that we factored it correctly right here at the very beginning. So that would be my answer, those two binomials next to each other. So let's go over to number 2. All right, number 2, we have a leading coefficient of 1 again. So I have 1k squared. So I'm trying to come up with the two factors that multiply together to create that trinomial. And to create k squared, I got to have a k times another k. And now I got to figure the rest out. So now we start looking at this back term here, the positive 40. And I start writing out the factors that can make positive 40. We have 1 times 40, make positive 40. We have 2 times 20. We have 4 times 10. And we have 5 times 8. And so those are all my factors. Now I'm going to look and say, all right, which group of factors would add together to be positive 14? Well, 1 and 40 make 41, so that's not it. 2 and 20 add together to make 22, so that's not it. 4 and 10 add together to make 14, and 5 and 8, they add together to make 13. So the factors that I'm going to choose that make the 40 is the positive 4 and the positive 10. So what that means is inside of my two binomials that I have constructed, I have to have a plus 4 and a plus 10. And so this would be my answer here. Now, I could always double check and make sure I did it right. So I do k times k makes k squared. K times 10 makes plus 10k. 4 times k makes 4k. And 4 times 10 makes 40. And I combine my like terms. We have k squared plus 14k plus 40. So it made our original problem, which means that we factored it correctly. All right, now we go to the third one. All right, similar situation. We have a leading coefficient of 1 again. So when we start making our factors here, we're going to ask ourselves, well, what times what makes m squared? Well, m times m make m squared. And then now we go to the number on the end. We have a negative 12. All right, so this one's going to be a little bit more tricky because I have to multiply together to be negative 12, but I have to add up to be negative 4. So we're going to have twice the number of factors. 1 times negative 12 makes negative 12. Well, so does negative 1 and positive 12. And we have positive 2 times negative 6 make 12, or negative 12. Negative 2 and positive 6 make negative 12. Positive 3 and negative 4 make 12. And negative 3 and positive 4 make 12. And I kept going. If I kept going, I would wind up repeating the factors I already have. So now that we have all the numbers I can multiply together to be negative 12, I want to find the pair that adds together to be positive 4. So I'm going to go through my factors. I'm going to add them together. So 1 plus negative 12 makes negative 11. So that one's not it. Negative 1 plus 12 makes positive 11. Well, that's not 4, so that's not it. 2 and negative 6 add together to be negative 4. Well, that's gave me a 4, but it's the wrong sign. Negative 2 plus 6 makes positive 4. There's my pair right there. No need for me to keep going because I found the two numbers. So what that means is I go back up to my two binomials that I'm constructing, and I have one of them that's going to be m minus 2, and the other one's going to be m plus 6. And so here is my answer. All right, now let's look at the one beside it. So, same scenario. We have a leading coefficient of 1 in front of the squared term. So we can go ahead and we can make our two sets of parentheses here that are multiplying together. And x times x makes x squared. So at the very front of each one, I'm going to put an x. Now we start finding our factors. Oops, I need to be blue. So I want to figure out what multiplies together to make negative 4. Well, positive 1 times negative 4 makes negative 4. Negative 1 and positive 4 make a negative 4. Positive 2 times negative 2 makes negative 4. And there's no need for me to write negative 2 and positive 2 because multiplication is commutative. So I don't need to write that because I've already have that here in that third one I just wrote. Now we are looking for the pair of numbers that will add together to make positive 3. So positive 1 plus negative 4 makes negative 3. That's not it. Negative 1 and positive 4 add together to be positive 3. And positive 2 plus negative 2 adds together to be 0. So the pair that adds together to make 3 is negative 1 and positive 4. So I go back into my binomials here. One of them is going to have x minus 1, and the other one is going to have x plus 4. And if I wanted to distribute it out and to see if it made the original problem, I could. It's a great way to check your answers. All right, let's go to number 5. Oops, too far. All right, same deal. I'm looking at it. The squared term has a leading coefficient of 1. Remember, if I don't write a number out in front of it, it's implied that there's a 1. So I can go ahead and pre-make my two factors that are multiplying together. To make n squared, we're going to have an n times an n at the very front. Now we're looking for our factors of the number that's on the very end. So I need to multiply together to be positive 70. I want to write them all out. So positive 70. Now, before when we had the positive sign, we had a plus sign in the middle. If I have a minus sign anywhere, I have to account for one of those numbers being negative. So 1 times 70 makes positive 70, but also negative 1 and negative 70 will multiply together to be positive 70. And then I start thinking, well, what else? 2 can go into it because it's even. 2 times 35. And so will negative 2 times negative 35. They'll multiply together to be a positive number. And I keep working my way down the list, try to figure out what number could come next. It ends in a 0, so 5 should be able to go into it. 5 times 14 will make positive 70. And negative 5 and negative 14 will make positive 70. So you got to know your multiplication tables pretty well here to be able to factor. And there's one more because it ends in a 0. 10 can go into it. Positive 7 and positive 10. Negative 7 and negative 10 all multiply together to be positive 70. Now I want to see which set of numbers will add together to make negative 17. Well, 1 plus 70 is 71. Negative 1 plus 70 is negative 71, so neither one of those are going to work. 2 plus 35 gives me 37. That's not it. Negative 2 and negative 35 make negative 37. Well, that's not going to be it either. 5 plus 14 make 19. Negative 5 and negative 14 make negative 19. Positive 7 and positive 10 make 17. Negative 7 and negative 10 make negative 17. I found my pair. Negative 7 and negative 10 will multiply together to be positive 70 and add up to be that negative 17 that's right there in the middle. So I can finish my factoring. We'll have a n minus 7 and a n minus 10. And that's our answer. All right, so we'll do it again here for number 6. Let me kind of draw a little line. I'm getting all over myself. All right, so we're looking at it. We have 3 terms again. The coefficient of the squared term is 1. So I can pre-make my binomials next to each other. N times n is going to make n squared. Now I'd look to try to find the factors that multiply together to be the number on the very end, positive 18. Well, because I have that minus sign, I have to account for both positive and negative numbers again. So 1 times 18 makes positive 18. So does negative 1 and negative 18. 2 times 9 makes 18. Negative 2 and negative 9 make 18. And then we got another set, which would be 3 times 6 and negative 3 times negative 6. So those are all the pairs of numbers that will multiply together to be positive 18. Well, now I want to find the ones that add up to be negative 9. It's that middle term. So I'm going to add these sets of numbers. 1 and 18 make 19. Negative 1 plus negative 18 makes negative 19. 2 plus 9 make 11. Negative 2 plus negative 9 makes negative 11, so I still haven't found the pair yet. 3 plus 6 makes 9. Closer, just it's not negative. Negative 3 and negative 6 They add up to be negative 9. There is my pair of numbers. So we can finish our factors. We'll have n minus 3 and n minus 6 will be what it factors to. Now, if you want to, I'll show you one more time the whole process of multiplying this out, and you'll see where these numbers come into play. When I start multiplying, so I take the n times the n, that gives me my n squared. And then I do n times negative 6, that gives me negative 6n. And then I take the next number, the minus 3, because I'm in here trying to check my answer. I get minus 3n, and then negative 3 times negative 6 makes positive 18. Well, you'll see where those numbers show up. The numbers show up. The negative 6 and the negative 3 are the same numbers we have right here. They'll add together to make that negative 9, and they'll multiply together to make that positive 18 on the end. All right, let's go to the next kind. So now we still have three kinds of trinomial here, and I keep making the signs a little different, so that way we have to work or look for different kinds of factors. The leading coefficient is 1. So I can start my process and say, all right, well, I want to factor this. So I have two binomials. M times m makes m squared. Now we got to make all those factors that make negative 60. So what times what makes negative 60? 1 times negative 60 makes negative 60. Well, so does negative 1 and positive 60. Positive 2 times negative 30. I'm just writing out my list. Negative 2 and positive 30 makes 60. 4 times 15. But one of the 15 would be negative to start with because I need a negative product. Or I could have the 4 be negative and the 15 be positive. 5 can go into 60 because it ends in a 0. So 5 times negative 12 makes negative 60. Same thing with negative 5 and positive 12. So I got a long list of factors this time. And I can keep going. 6 times negative 10 make negative 60. And so do negative 6 and positive 10. So I want to test out all those factors to see what will add together to make that negative 4. Well, 1 plus negative 60 makes negative 59. That's not going to work. Negative 1 plus 60 makes positive 59. That's not what I need either. 2 plus negative 30 makes negative 28. That's not going to work. Negative 2 plus 30 make positive 28. Well, that's not my negative 4. I keep going down the list. 4 plus negative 15 makes negative 11. Nope. Negative 4 plus 15 make positive 11. So my sum is getting smaller, but it's still not where it needs to be. 5 plus negative 12 makes negative 7. That's not it. Negative 5 plus 12. Positive 7. Nope, still haven't found it yet. So I keep going. 6 plus negative 10 makes negative 4. And negative 6 and positive 10 make positive 4. So I finally have the pair of numbers. Positive 6 and negative 10. So I'm going to write m plus 6 in one of them. And I'm going to have m minus 10 in the other one. And if I multiplied that all the way out, it would make my original problem. All right, let's look at number 8. I want to factor this. The coefficient of the squared term is 1 still, and it's going to be 1 on this entire practice sheet here. So I'm going to pre-make my binomials. I'll have m plus or minus something times m plus or minus something else. Now, I figure out the factors that make negative 6. So what times what makes negative 6? 1 times negative 6 makes negative 6. Negative 1 times positive 6 will make negative 6. 2 times negative 3 will make negative 6. And so will negative 2 times 3. And if I kept going, I'd wind up repeating the pair of numbers I have, so I stop. And so I'm going to add these things together and see what I get. I'm going to start from the bottom this time. Negative 2 plus 3 makes positive 1. Oh, that's not my negative 5 I need, so I need to keep going. 2 plus negative 3, that makes negative 1. That's not it. Negative 1 plus 6 makes positive 5. Well, that's not my negative 5. I got one more pair to try. 1 plus negative 6 makes negative 5. There it is. There is my pair of numbers. This thing's going crazy on me. My pair of numbers that I need to use. So I'm going to have I have a positive 1, so I write plus 1. And I have a negative 6, so the other one's going to have a minus 6. So there's my answer. All right, we only have a couple more. So now let's look at a problem like number 9. And so now we're looking at this and they say, well, wait a minute. I have p squared, but I don't see a p to the 1 power, and I just see a number on the end. It may be helpful when you're first starting out learning this to write this showing every term. So I have p squared. We really have plus 0 p's minus 100. So that way it looks like the other ones. Now we're trying to factor, and that leading coefficient of the squared term is 1. So I can go ahead and pre-make my two binomials that be multiplying together. Each of those will have a p out front. Now I try to find the factors that multiply together to be negative 100. All right, so anytime I see a minus sign in my problem, I have to account for both positive and negative factors. So 1 times negative 100. Negative 1 times positive 100. 2 times negative 50. Negative 2 times positive 50. 3 doesn't go into it because the sum of the digits isn't divisible by 3. But 4 does. 4 times negative 25. Negative 4 times positive 25. And let's see, we have 5 times negative 20. Negative 5 and positive 20. And we also have 10 times negative 10. So we have kind of a long list of factors here. And we're trying to see which ones will add together to make 0. So I'm working my way adding. 1 plus negative 100 is negative 99. That's not it. Negative 1 plus 100 is positive 99. That's not going to be it. 2 plus negative 50 makes negative 48. That's not it. Negative 2 plus 50 make positive 48. Nope. Positive 4 and negative 25 make negative 21. Nope. Negative 4 and positive 25 add together to be positive 21. No, I still haven't found my 0 yet. Positive 5 and negative 20 add together to make negative 15. Nope. Negative 5 and positive 20 add together to be positive 15. Nope, we got one more pair of numbers to try. Negative 10 and plus positive 10 adds together to be 0. There's my pair right here. So it's the pair of numbers that multiplied together to be negative 100 that added up to be 0. So I can put in a positive 10 into one of my factors and a negative 10 into the other. So p plus 10 times p minus 10 is what that original problem, p squared minus 100, would factor to. All right, and then we go to number 10. So similar, but I got different numbers. So again, we have the squared term, and then we just have a number right there behind it that we're trying to factor. So I'm going to take the same approach. I'm going to rewrite this as r squared plus 0 r's minus 25. And we're going to start trying to factor. Well, the coefficient in front of the squared term is 1 again. So I can go ahead and make my factors where I have r plus or minus some number times r plus or minus another number. Because r times r makes r squared. Now I look and figure out what times what makes negative 25. Well, this list isn't going to be very long. We have 1 times negative 25. Make negative 25. Also, negative 1 times positive 25 will make negative 25. The only other numbers that we have that will multiply to be negative 25 is 5 and negative 5. And I don't need to write on the next line negative 5 and positive 5 because it's the same pair of numbers. Now that I have my list of all the factors that will times together to be negative 25, I want to find the ones that will add together to make 0. 1 plus negative 25 makes negative 24. That's not it. Negative 1 plus 25 make positive 24. That can't be it either. Last pair to try is positive 5 and negative 5. They add together to be 0. There's my pair. So I found the pair of numbers that times together to be negative 25 that add together to be 0. So I'll have r plus 5 as one of my binomials and r minus 5 to be my second binomial. All right, 2 more to do. So now we're back to our normal looking trinomial where we see all 3 terms, the squared term, the term that's raised to the 1 power, and then just the number. And so again, we have a leading coefficient of 1, and that, well, as we progress forward with our factoring skills, when that's not a 1 out front, it makes it a little bit more challenging to do. But I'm going to pre-make my binomials. And now, I'm ready to find the factors that make 100. All right, so numbers that multiply together to make 100. I see a minus sign, so I got to include both positive and negatives. So 1 and 100. Negative 1, excuse me, 1 and negative 100, sorry. Negative 1 and positive 100. 2 and 50. Or negative 50. One of the numbers has to be negative because negative and a positive is what, actually, I'm wrong. Let me back up. I got my signs wrong. To make positive 100, positive 1 and positive 100 will make it. Or negative 1 and negative 100 will make positive 100. Positive 2 and positive 50. Negative 2 and negative 50. Positive 4 and 25. Negative 4 and negative 25. 5 and 20. Negative 5 and negative 20. 10 and 10. Negative 10 and negative 10. So those are all the numbers that multiply together to make positive 100. Now, I want to find the pair that adds together to be negative 20. So I'm going to start adding those numbers. 1 and 100 make 101. Negative 1 and negative 100 make negative 101. Positive 2 and 50 make 52. Negative 2 and negative 50 make negative 52. So I'm keep going until I get to see that negative 20 for my sum. 4 plus 25 makes 29. That's not it. Negative 4 and negative 25 makes negative 29. That's not it. 5 plus 20 makes 25. Nope. Negative 5 plus negative 20 is negative 25. Nope, that's not it either. 10 plus 10 makes 20. Right number, but it's not negative. Negative 10 plus negative 10 make negative 20. Finally, we found our pair. So both numbers have to be minus 10 inside of the parentheses. So m minus 10 times m minus 10. And so this is an answer. However, it probably will not show up that way on any standardized test. If you have the same thing times it multiplying to itself, you can write it. In this case, I can write it as m minus 10 to the second power. That is the way we want to write our answer. So if I have the same binomial times itself twice, I just write the binomial one time and raise it to the second power. All right, last example. So we have a leading coefficient again of 1x squared. So I'm going to make my two binomials, and each of them are going to have an x in the front because x times x makes x squared. Now I have to create my list of factors that multiply together to be this number on the end. So positive 4. Now I don't have a negative sign anywhere in my problem, so I don't need to include the negative numbers. So I'm going to say 1 and 4, 2 and 2. Now I want to look and say which pair will add together to make positive 4. Well, 1 plus 4 makes 5. That's not it. 2 plus 2 makes 4. There's my pair of numbers. So both of these binomials with the x's have to have a positive 2 on the inside to create that product if I multiplied it out. We got one step to go because it's the same x plus 2 times itself. I'm going to write my final answer as x plus 2 to the second power. There's my final